Okay, let's now talk about line structure. Line structure is in actual fact basically a faster way of representation of a structure for organic compound. All right. So for example, if we have a structure which is like that, let me start out with this first. Okay. Then instead of having to write in that manner to quickly represent the structures, we can do it in this manner, which is actually pretty fast. So it means that as far as for all the terminal end is concerned, right? Each of the terminal end in actual fact represents CH3, and you probably will be able to see that the around the band, okay, the two band, it represents actually CH2 actually. All right. So aside to that, we can give another example. All right. So in this example that we have is that we might actually want to go for the line structures, say in this manner. All right. So I draw this. So basically, from these structures, you are able to tell that the terminal ends. Let me circle them. These two are interpreted with similar to this. So both of these are in actual fact CH3. Similarly for this and this. Okay. However, you could see that as far as for this one is also CH3, yeah? Okay, because they're all terminal. So as far as this is concerned, all right, this in actual fact actually represents a CH. Okay, so let me now write the structural formula on the side, so you could actually see it clearly. So this is actually now being represented by that. And to wrap it up, last but not least, this carbon here is actually this carbon. Okay. So in a nutshell, just want to add that when you look at the line structures drawing, all right, to sum it up, when it is actually at the terminal end, it represents CH3. When it's actually at the band, we call it CH2. And when it's actually a Y junction, we call it CH. Okay. And when it's actually a cross junction, it means down there is it's actually just a carbon only. All right. Thank you. Hi everyone. Now I'm going to run through the formula that's been used in organic chem. So we have molecular formula, display, and structural. As everybody knows that as far as molecular formula is concerned, it's just basically depicting the various types of atoms and the numbers of atoms. Then when you come to display formula, you have to be very specific. You have to display every single bond between the atoms. Therefore, if you have written this as OH, then that will not be correct. This will then actually becomes what we term as a structural formula because it depicts the structure, not the displayed formula, as displayed formula require you to show every single bond between the atoms, and the bonds may be single or double or even triple. So this is a structural formula. And as part of another alternative way of displaying the structural formula, you could actually use the line structures to do that. So remember earlier we discussed about line structures. So in this case, the line structures will be these. Okay. So this point here is actually your CH3 representation, and this just represents your carbon. Of course, another example that we look at is none other than your butene. All right. So in this case, the double bond is between the second and the third carbon. All right. And in the structural formula, as you can see down here, we have actually depicted them with CH, CH. So you must be able to interpret the fact that between these two carbon, there's actually a double bond. So again, we'll now look at actually the line structures for actually butene. So butene got 4 carbons. In this case, it will be 1, 2, 3, 4. All right. And you actually have a double bond between the second and third. So that's how you display it. All right. So aside to that, we'll look at a few others more interesting structures. For example, this one we look at will be none other than a cyclobutane. All right. So it just so happened that the molecular formula is still C4H8, but in this case, we're going to depict that by actually drawing the display. So in terms of the display formula, you could actually use a line structure to depict it. Okay. Obviously, the alternative to do it is to actually do it in this manner to display every single bond. But actually, you don't have to. You could actually just use this line structure to depict. So you probably can see that this one takes a lot of effort to do that. All right. So clearly, in this case, to summarize it, we could actually let you know that as far as for C4AH8 is concerned, all right, they both the display and the line structure, they would have accepted it. Okay. So aside to that, we also have give you the last example, which is none other than your benzene, which is the same thing. Benzene actually has 3 sets of double bond. So some people say that you need to depict in this manner, but as you probably remember, because the double bond actually pops, all right. So sometimes it could be here, sometimes it will actually revert to this, all right. Hence, because of that, the best and most accurate way to depict it is to put a circle inside, because the electrons are in actual fact hopping, all right. So both these two representations are both of structural and as well as display formula. Thank you.